All right, you guys, here we are starting chapter 5. So what you need to know about chapter 5 is that there is a ton of Algebra 2 stuff and prerequisite knowledge that you need in order to be successful in pre-calculus. So good news, bad news here. This is actually not notes. This is worksheet 0. It's kind of like preparation, I guess, or kind of an intro to the chapter, but we need to review some stuff that you guys did in Algebra 2. The good news, bad news is the fact that this is not new info. This is stuff that you have learned before. However, you probably forgot some of the stuff. For example, do you know what a linear equation or function looks like? This is what the equation looks like, y equals mx plus b. This is actually pre-algebra and algebra 1. But they're straight lines, positive, negative, something like that. Do you know what a constant looks like? A constant function means y equals a number, like y equals 3. It is a horizontal line. So I'm going to go through all of these different functions, and these are things to refresh your memories on, and then we're going to practice graphing them, okay? You know what a parabola looks like? It's a U-shape. The equation for that basic equation is y equals x squared. You also know that to make that parabola go upside down, you make it negative x squared. So just remember that putting a negative sign in front of these functions flips it upside down, for lack of a better word, reflects it across the x-axis. Y equals x to the third. This is a cubic function. It looks kind of like a snake. Again, to make it negative or to make it go down, you just add a negative sign in front of the x cubed. Square root functions. When I taught algebra 2, I called this the sprinkler. It has an end point, not an arrow, and it goes in one direction. It looks kind of like a square root. The reason why, or a sprinkler, the reason why it has an endpoint and not an arrow here is because you can't square root negative numbers. As you know, we don't graph imaginary stuff on a normal coordinate plane. Also, cube root function. It's kind of the inverse of this. If you remember inverses from algebra 2, it has that same shape, except it's reflected along the line y equals x. So it looks like a snake also, but it is more horizontal than it is vertical. Okay, so that you can cube root negative numbers. That's why there's arrows on both sides. The absolute value is a v. We also have the exponential and the log graph. So remember, exponential graphs have an asymptote that look like this, and y equals 2 to the x or 3 to the x or 4 to the x, whatever, it skyrockets. It gets really, really big, really, really fast, hence that shape. The log graph is the inverse of that. It has a vertical asymptote, and it looks kind of like a sprinkler function, except it has an arrow on both sides. And then a couple other things just to review from first semester. Do you remember what the sine graph looks like, what the cosine graph looks like, and the tangent graph looks like? So just remember those shapes. These are all going to come up in this chapter. And one thing that I skipped that I wanted to mention, this is something that we've talked about several times in this class, but I just wanted to kind of refresh your memory on the basic parabola equation in terms of shifting. So we're going to be doing a lot of shifting and needing to remember those properties as well throughout this chapter. And we talked about this when we did cosine graphs and sine graphs. How do you move it right, left, up, and down? So just remember that this constant that is multiplied in front, we refer to that as the a value. And in the case of a parabola here, because this is a quadratic function, the a value just makes it fatter or skinnier and also tells you whether it opens up or opens down. So if a is positive, that's your normal U-looking shape. If a is negative, that tells you that your U is upside down. It looks kind of like an N. Remember that the negative h inside the parentheses actually means right h. So if this was a positive h, that would move left, whatever the number h was. And then this plus k hanging out on the outside means it moves it up a certain number of units. So these are all things that we talked about earlier this year, but these are things that are going to play into the functions that we're going to be graphing this chapter also. So with all of that in mind, I actually want to practice graphing some of these. You need to be able to graph stuff in different functions and different looking formulas. You need to be able to have ideas in your head of what they're going to look like. You need to be comfortable with piecewise functions. Again, this was an entire chapter that you did in Algebra 2 where it was functions and certain pieces of them. And so I'm going to go through these kind of slowly so that we can get all of these graphed together. And this is kind of going to serve as our intro for the chapter, okay? So this very first equation here, we've got this function defined as f of x, and I'm going to graph this, and this all on this graph together. And what you'll notice here is that these domains are restricted. And so you should know, you should have an idea of what 2x plus 3 looks like in your head. It's a line, a straight line with a positive slope that starts on positive 3. So my first dot would go right here on the y-axis called the y-intercept. And then the 2x means your slope is up 2 over 1. So you'd have a dot here, up 2 over 1, put a dot there, up 2 over 1, put a dot there. And that line is the line you would connect. However, a piecewise function tells you not to graph the entire line, but only graph a piece of it. And they want the piece of the line for all x values less than -3. So the way I'm going to start kind of tackling this is I'm going to take -3 and I'm going to plug it into the equation. So when I get 2 times -3 plus 3, I get -3. That means when I plug in -3, I get -3. And that's going to be my very first dot on this graph for just this piece of the equation. That's the only one that I'm going to be looking at right now. And it's going to be an open circle. Do you guys remember open circle, closed circle? Because this is not a less than or equal to symbol, that means that it is an open circle on -3, -3. So that's going to be my first dot that I'm going to place, -3, -3, open circle. And I want all x values less than that. So remember that the line started here at 3 and then I went up 2 over 1, up 2 over 1, up 2 over 1, whatever. So that line was supposed to look like this. However, I only want it to start here and go this direction. So I just have to use that slope, the slope right here, which is 2, up 2 over 1. That means the same thing as down 2, left 1, down 2, left 1, down 2, left 1, whatever. X less than or equal to -3 means that it goes like this. So I have now graphed this piece of the piecewise function. So again, starting at x equals -3, which is right here, with an open circle, and I'm only using x values less than that. So just continue that line. It's kind of like if you wanted to graph the entire line on this, and then just erase this part of the line so that it starts here and goes in this direction. I know it goes in this direction because it's for x values less than -3. So that means x is -4, -5, -6. It's going in this direction. Okay, let's do this middle part, the parabola. I'm going to do a different color so it doesn't get too confusing. But let's talk about this one now. So this is a parabola shifted down 4. So the vertex of the parabola is 0, -4. You should be able to remember that pretty quickly from your parabolas chapter from Algebra 2. Remember, there is no number in here with the x, so that means that it's moved left or right 0. But this means down 4, so that's where my vertex is. And it's giving me 2 endpoints, -3 and 2. So what happens when I plug in -3 and what happens when I plug in 2? I'm just using this equation here, and I'm using these 2 endpoints, and I also have an idea of where the vertex is. So that's going to give me a really good idea of what this parabola is supposed to look like. Remember, it's a parabola moved down 4, so it looks something like this. Move down 4, but I don't want to graph the entire parabola. I'm only starting it at -3 and ending it at 2 for the x values. So I think fastest way to probably do this, I'm going to plug in -3 to the equation here. So when you square a negative number, remember it turns positive, so it becomes 9 minus 4, which is 5. And when I plug in 2 here, I get 4 minus 4, which is 0. I'm going to just graph those 3 points really quick, and those also both have open circles on them, so just keep that in mind. They're not closed circles, they're open circles. I'm going to graph that in blue. So 0, -4 is a dot on the graph. All the dots are closed dots except for the ones that are defined here. So they're all like normal filled in dots except for the endpoints that don't have an equal sign with them. Anyways, -3, 5, where's that? Right here, open circle. And also 2, 0, open circle. Cool, so it's this part of the parabola, not with arrows in both directions because they only want a certain piece of the parabola. They only want the parabola between -3 and 2. So it would be incorrect to put an arrow here. That indicates that it continues this direction. but that is not following this rule right here. Only between x value of -3 and x value of 2 with open circles on both of them. Just another reminder here in terms of like lingo for this chapter, these are all functions. So if you were to have an arrow going this direction or an arrow going this direction, remember the vertical line test? The graph would not pass the vertical line test, it would fail in that case, and that would not be a function. This is all Algebra 2 review stuff, but your graphs are all supposed to be functions. That's what this notation means. So that's a quick thing that you can kind of take a step back and make sure that your graph passes the vertical line test, because it should. That means it should not, a vertical line should not touch the graph in more than one location. Okay, this last thing looks kind of weird, but this is just a horizontal line. It's a constant function. Y equals 6. So remember, that's just a horizontal line that looks like that, but they only want it for x equals 2. That means when x equals 2, y equals 6, and there's going to be no arrow or anything on that because it is strictly only one dot according to this rule. So what I'm going to do in red, just to keep it straight, 2, 6 is a filled in circle right there. And it's a filled in circle because it's x equals 2. Okay, kind of weird. Let's try another one. Let's look over here at this one. Okay, so let's see, -3x. So that's a linear function. It starts at 0 and it goes down 3, right 1, down 3, right 1, but they don't want the entire line graphed. They want it to start at x equals -1 with an open circle because of this thing. So starting at x equals -1 and moving to the left because x is less than -1. So also using x is -2, -3, -4, whatever. When I plug in -1 to the equation, I get 3. That's going to be my first dot. So -1, 3, and it's going to be an open dot. So it looks right here. And then I'm just supposed to graph the line, the y equals -3x, this equation, but only going x less than -1, which means, so if my graph, my slope was -3, that would be down 3 over 1, down 3 over 1. But I don't want that part of the line, I want this part of the line because it's x is less than -1. So I'm actually going to go up 3 over 1, up 3 over 1. And that's the piece of the line that they want. I'm going to put a dot up 3 over 1, up 3 over 1. Remember that they're all filled in dots except for the endpoint if it doesn't have an equal bar with it. Okay, so that takes care of the black section of the line. Remember, you could graph the entire line if you wanted to and then just erase the part that they don't want because they only want x less than -1. So that means it has to start at the x value of -1, which is right here, and go this direction. Anything less than -1 in terms of the x-axis. Okay, now let's do this one. This is kind of weird. Remember that shape is one of those that looks like this, and it has an asymptote, and they only want it between -1 and 2. So I am going to plug in those endpoints. I'm going to do -1, and I'm going to do 2. And maybe I'll do 0. Sometimes it's good to just plug in a number, any number, just to have a better idea, any number in between these, just to help you graph it. So I'm going to plug in -1 to this equation, 2 to the -1, negative exponents, that means 1/2. When I plug in 2 to here, I get 4. When I plug in 0 to here, anything to the 0 exponent is 1. Okay, cool. I'm just going to graph those. Keep in mind both of these are going to be closed circles. So I'm going to have closed circles everywhere for this part. I'm going to do -1, 1/2. So where's that? -1, 1/2. Closed circle right there. 2, 4. That's right there. And then just because I didn't really have an idea of what that shape is, I know that the shape looks like this, but it sometimes is helpful. You guys can pick as many points as you want in between these two just to help you connect the dots to get the accurate shape. But 0, 1 is another point on there. And you should know exponential graphs have this shape. And so from here to here, I'm just going to connect them, and I do not have arrows on either direction because this blue part is strictly between -1 and 2. I'm just going to connect those, and that takes care of that piece of the function. Okay, another one I have is this one. So again, this is a horizontal line, y equals 6, and it's only between 2 and 5. And so just be really careful here on the open circle, closed circle. I'm putting an open circle at x equals 2 and a closed circle at x equals 5. And it's just a horizontal line, y equals 6, starting at 2 and ending at 5. So 2, 6 is right here, open circle. That's really good that that's an open circle because this one is a closed one. If they were both closed, that would make it not a function. That's why we have all this open circle, closed circle nonsense. Anyways, and then going to 5 with a closed circle, just connect the horizontal line. Okay, so there's that part. And now we've got one more, and I'm running out of colors, but let's do this one. This is an absolute value graph with a vertex at 7, 2. You should know that right away by just looking at that graph. It looks very similar to a parabola, except it's the absolute value bars instead of a parentheses squared. But I'm starting by plugging in 5 with an open circle, and I know my vertex is 7, 2. That fits in between those two numbers, so that's just going to help me graph and help me get the right shape. And the endpoint they want me to stop at is 10. So I'm going to plug in 5, this endpoint to this equation. When you do the absolute value of 5 minus 7, it's -2, but since it's absolute value, make it +2. Times 2 is 4, plus 2 is 6. Cool. And then when I plug in 10, 10 minus 7 is 3, times 2 is 6, plus 2 is 8. So those are going to be my 3 dots. This one is open. This one is closed. And that's just, again, because of this and this. Okay, so 5, 6, where's that? 5, 6, open circle. Okay, but it's already closed in, so no big deal. You don't have to erase it. It's closed in by the red part, which means it's open with the green part. 7, 2 is right here. And then 10, 8 is right here. And I know that this was my vertex because of the 7 and the 2 in the original equation. So now I have an idea of what the shape looks like. It's a V. It goes like that. And I'm not putting an arrow right here because it didn't say anything greater than 7. It said between 5 and 10. So that means it stops here. So it would be incorrect to put an arrow here. Stop at 10. That's what that means. Okay, you guys are doing great. I know this is a ton of Algebra 2, but this is going to be very, very good review for us. I dare you to pause the video and try number 3 and then check your answer with mine, but I'm going to talk through it anyway. So here we go. We've got a parabola for this. Vertex is -3, 6. That's probably going to be helpful. They also want me to plug in -5 and -2. Those are these endpoints. So I'm using this endpoint, and I just recognized right away that the vertex is -3, 6. That fits in between those two endpoints, so that's going to help me have an accurate sketch. When I plug in -5 to this equation, I get -2 squared is 4, -8 plus 6 gives me -2. That shouldn't be too difficult for you guys to be plugging numbers in. When I plug in -2, I get 4. And so that is going to be the first part of my piecewise function. Be really careful. The 5 is a closed circle and the 2 is an open circle. So let me graph that. The 5 is a closed circle, -5, -2. I have a vertex of -3, 6. And then -2, 4 is an open circle. Okay, cool. That looks like a good looking U shape to me. So that's the first part. Ooh, now we've got a sprinkler. They want me to start by plugging in -2 and end by plugging in 7. Let's see what that looks like. And I might want to pick another number just to help me graph this, but let's just see if I can figure out the shape with just those two. It's always okay to pick more numbers that fit within these x values to help you graph an accurate sketch. When I plug in -2 to here, I get 0, with the square root of 0 is 0, plus 4 is 4. And then when I plug in 7, 7 plus 2 is 9, square root it gives you 3, plus 4 is 7. Let's just see what those look like. Those are both going to be filled in circles. So I'm going to see what that looks like, and I might need some more points, I'm not sure. -2 comma 4. Oh, I just recognized that this line should go somewhere else. I graphed my dot incorrectly. The -2, 4 is here. My bad. Anyways, filling it in now for the sprinkler function, -2, 4. Filling it in right there. And then 7, 7. That's right here. And it's supposed to look like a sprinkler. Boom. Okay, you can get some more points in here if you want to. What would be an easy point to plug in? Maybe if I did +2. The reason why I'm picking +2 is because this is a square root function. So +2 plus 2 gives me 4. When I square root that, that might help. Where's 2 comma 6? I was a little bit off with my sketch. Whatever. That's just going to help, okay? And then the last part is a horizontal line at -1 for everything bigger than 7. So starting at 7, the y value is -1, and it's an open circle, and then it continues to the right because it says x is greater than 7. So that means use x equals 8, 9, 10, whatever. So 7, -1 is my first dot with an open circle, and then it's a horizontal line that continues this direction. Put an arrow on that one because it doesn't have an endpoint. It's at 7 to the right forever. Okay. I'm going to stop there, you guys. You don't need to worry about number 4 for right now, but that is quite a blast from the past for Algebra 2. You're probably going to have some questions, so make sure you reach out to me or your teacher and make sure that you understand and remember all of these properties of functions from Algebra 2 before we head into the chapter. It's going to be really important when you guys get to calculus next year as well. So there's your recap. Let me know what questions you have. Thanks for watching. Have a great rest of your day.